Well, let's take a look together. Could we have seen 0 tokens so far? No, when we've seen 0 tokens, the red dot has to be really far to the left. Currently, the red dot suggests that we've already seen an E and a plus. The plus alone takes up 1 token, so we can't be here. All right, but could we have just seen 1 token? Well, since we've seen an expression and a plus, and the smallest expression is itself 1 token, we need to have seen at least 2, so we can't be here. However, we could have seen just 2 if the input so far was int plus. We've seen 2 tokens, and one of our states would be exactly this one. Int reduces to or can be rewritten from E using one of the rules in our grammar. The plus is a terminal, so it always stays the same. And here's where we are. How about 3? This is a little trickier. In our grammar, if we had seen 3 input tokens, our red dot wouldn't be right here after the plus. It would be over 1 more, right? Or something a little different would happen. It's very hard to have a string in the language of this grammar where after 3 tokens you've just seen a plus. But surprisingly, 4 tokens does. Let's make a little room and take a look and see why. E can be rewritten by int. E can be rewritten by int. This plus stays the same. So the 3 of these together, E plus E, are themselves 1 more E. So conceptually, from the parser's point of view, what we've seen so far is an E and a plus, assuming we've done all these rewrites over here on the left, and we're looking for a little more input. So in fact, we could have seen 4 input tokens, int plus, and been in this parsing state. And this might seem a little counterintuitive, but remember, the glory of parsing, or the glory of context-free grammars, is that a very concise grammar notation stands for an infinite number of strings. Even this very simple grammar has an infinite number of strings in its language, so it shouldn't be surprising that longer strings than 2 can have very concise parse states. 5 tokens isn't going to work for the same reason that 3 tokens didn't work. The dot would have to be in another place. However, if we were to add a few more ints, this trick that I've done here of reducing int goes to int goes to int, if I had 1, 2, 3, 4, 5, 6 tokens, I could also be in the same state. So 2, 4, 6, 8, the pattern repeats.